Thank you all for coming today. We'll be starting the seminar right now. So I just want to say thank you for coming. Welcome everyone online as well as in the room. I'm Joseph Troba. I'm a PhD student in extractive metallurgy. I'm a member of the mining department seminar committee. The committee organizes the seminar series and invites speakers to come and address students, faculty, and any interested industrial professionals on a variety of mining topics. Since we're on Zoom today, this is just a friendly reminder. Anyone on Zoom, please mute yourself while the speaker is talking. We'll do a question and answer session at the end. Today, I have the pleasure of introducing Ray Valentine from Rack Development. Ray has worked in the resource industry since 1981. He has operated as an independent consultant since 1986. He is based in Western Australia. So good morning, Ray. Thank you for getting up so early. And his work has taken him throughout Australia and on multiple assignments to Africa, United States, China, and Mongolia. He is known for his work in the field of mine control, which included the development and commercialization of the Pitram product, one of the world's leading mine control systems for underground mines. In his consulting, he has worked with and assisted in the development of time usage models for multiple clients. Without further ado, I'd like to pass it off to you, Ray. Thank you so much for coming to speak with us.
Right. Can you give me a thumbs up if you can see the screen? Okay, there's a little bit of a story behind this. It was a written paper initially. Back in 2010, I spoke at the AusIMM Underground Operators Conference. And afterwards, one of the organizing committee asked me what my next paper was going to be. I said, I'd like to do something about time usage because I think it's pretty badly handled in our industry. So it took 10 years. It's proved to be quite a difficult topic to write about. I had many attempts at getting started and it just didn't go anywhere. So eventually that same friend about 3 years ago said to me, come on, you got to get this done. And so I forced myself to do it during COVID. So here we are. The paper associated with this was published late 2019 and is available both on my LinkedIn profile and on the AusIMM online bulletin for download. I'd like to make some special thanks. Mark Adams is watching here today. He's always been supportive. Some friends and colleagues, Ori Maudsley and Ian Cameron, and a particular thanks to Corin Farrelly, who's a well-known writer and thought leader in our industry, with a wonderful turn of phrase. I kept sending him paragraphs and saying, does this make sense? With that, we'll get going. People who've worked with me will know I have two fundamental principles when it comes to time usage, availability, and that sort of thing. Principle one is never, ever, 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 ever enter into any discussion as to how availability should be calculated. And principle two, stick to principle one at all times. No, I'm not really joking. This is an incredibly emotive topic. And if we start the conversation, we end up all night and not coming to a resolution anyway. So let's look at some reasons why this is such an emotive topic. I think the fundamental one is that we use equipment KPIs to measure people's performance. The maintenance managers measured on equipment availability. The operations managers measured on equipment utilization or tons per hour, meters per hour. So we're using our equipment time usage model to measure people's performance. And that immediately introduces an incentive for people to bias the outcomes of the models. So they bias the way data is captured. They play with the structure of a time usage model and change formulae for calculation. I don't know how many of you have been through the experience of having consultants come on site. Oh, we fixed the availability. They just changed the way it was calculated. And the other big thing is that in many cases, the people are being measured by this data, but they don't actually have control of how it's captured. So our poor maintenance man might be measured on availability, which is captured through a mine control room or dispatch system that's been run by operations. So there's a lot of incentives for people to break whatever model gets set up. So first definition, what is a time usage model? Well, it's certainly a taxonomy, and we're dealing with actual elapsed durations, and we consolidate these into a structured hierarchy. I think it's important to know that we're dealing with durations. So here's some simple examples. I can't remember where I got this one. I don't like the colors, but the core of the model is okay. I'll highlight one box here. When I see a box like this in a block diagram for a time usage model, I get a bit concerned. I would think that in this case, they would probably be doing all their calculations against the light green required hours rather than the total calendar hours. I tend to call this box the cheating box. Here's another one. It has an interesting little quirk in that the maintenance, or what they've called downtime, is duplicated as contract maintenance or non-contract maintenance. Here's another one that I've worked with quite extensively. It's a standard for one of the bigger mining companies. I feel it's too complicated and it confuses equipment time usage with process time usage. Some of the language is a bit difficult too. I was working in a situation where the nationals spoke English as a third, fourth, or fifth language, and I never managed to explain what unscheduled loss other actually meant. I'm sure most of the expats who spoke English there didn't know either. So too complicated and confusing process and equipment. So why do we need a time usage model? I struggle to articulate this actually, and I've asked many people. We definitely are looking for consistent ways of calculating our duration-based performance indicators. It defines the rules for calculations. We can get alignment between stakeholder groups, and we can have various systems singing to the same song sheet. A number of people I've talked to about this topic said time usage model is an essential part of interoperability. I don't know, some of you may have seen the paper that Colin Farrelly and I co-authored back in 2015 for Amira on interoperability. It's another hot topic. I'm going to digress a little and have a glossary here. The word time gets used in many different ways in these discussions. I remember sitting in a meeting a few years ago where a young engineer had been going on about, I can't get the times, I can't get the times. And it took an hour and a half before I figured out he was actually talking about the durations. So for the purpose of this paper, I'm going to try and stick to a standard where the word time is only used to represent an instant in time. And where we've got a duration between two times, I'll call that a period. And when we aggregate a whole bunch of those periods together, I'll call that hours. In underground mining, we have a lot of constraints that make it difficult for us to collect data. Obviously, communications, both voice communications and data communications. For time usage, I feel we are still very dependent on human intervention, and there's lots of limitations in technology, although that is changing quite rapidly. I'm going to assert a number of rules throughout the session. So rule one, is when you're designing a time usage model, you must take into account your capability of capturing valid actual data. There's no point in having a complex time usage model if you can't capture the data. We exist 24 hours a day, 7 days a week for 365 or 366 days a year, just as our equipment does. And in some situations, we can record some of those hours, we can't record others. I think it's important to record all those hours. We do have situations where we can't. For instance, there are still mines in the world that do not work 24 hours a day, 7 days a week. I have a client mine in Queensland that works, the mine works 4 12-hour day shifts a week, and that's enough to keep the mill busy. But where possible, I really try to capture equipment hours 24 hours a day, 7 days a week. For the purpose of this discussion, I'm not going to deal with those mines that don't work 24 hours a day, 7 days a week. And so recorded hours and calendar hours will be synonymous. I have a little story, a horror story about a mine that worked 2 11-hour shifts a day and had a half-hour hot seat changeover in the morning. So that left a 2.5-hour break in the afternoon. And all availability and utilization was reported against the 21.5-hour day. Now, there were a lot of things went on in those 2.5 hours that weren't recorded. Maintenance took advantage of that time, and the operation would do work to catch up during those hours. And the maintenance work was never recorded, and the operations only recorded the outputs, the tons or the meters drilled. So it boosted the performance rates and kept the availability and utilization high, but it wasn't true. Then that operation decided to go to 12-hour continuous shifts. And surprise, surprise, within 2 years, the mine had closed down. They sort of believed their own lies. So it's a danger to have unrecorded hours. So I'm going to assert rule 2, which is record all hours for all equipment. And rule 3, the people using this data must understand the basis by which it's captured. I continue to be amazed by going into senior meetings at operations where people in the meeting don't actually know how the figures they're seeing have been arrived at and what level of massaging has gone on. Okay, I'm going to break our calendar hours up into 3 boxes: utilized, standby, and the red box. Utilized hours, these are when the equipment's working or its engine's running. Now, this line between utilized and standby becomes fairly fuzzy. We're getting more and more into electrical equipment, which can actually not be consuming power as part of its various sections in its duty cycle. So the idea of engine running and using power is limited. It works well for, say, a diesel-powered loader or truck. I was working with a mine in northern Canada recently, and in winter they leave the truck engines running when they're parked up, but they wanted to treat that period as standby. So this differentiation between utilized and standby is a bit fuzzy. Standby, so this is my basic rule for utilized. Standby, I have a rule for that. It's when the equipment is not being used, it's not turned on, and operations are entitled to take it and use it. Going back to this differentiation between utilized and standby, with battery electric vehicles, we're seeing a practice of using seat time as the measure for whether equipment is utilized or not. And I think that's going to break down as we go more and more to autonomous equipment. So it's not an easy differentiation to define. Standby, fairly simple. It's not turned on, but you're allowed to take it and turn it on. And we'll move on to the red box. Now, we can't even get agreement on what we call the red box. It's often called downtime. It's sometimes called maintenance. I'm in the school of thinks it should be called maintenance. I was in a workshop recently where a very experienced maintenance manager that I have a great respect for commented that a category in the time usage model should not be given the same name as a department. I sort of understand that, but I'm going to stick with maintenance for now. Then the question becomes, do we include all maintenance? And we'll talk later about this area called opportunity maintenance, where repairs or work is done on equipment when it's not required by the operation. I would argue that that's maintenance and belongs in the red box. And does this box only contain maintenance hours? It's not completely clear cut. I would argue yes, but you have examples like a chute in a fixed plant and the chute gets blocked. Is that part of the red box? Or is that an operational cost? So nothing's black and white. The other big area with maintenance, particularly with mobile equipment, is when does a maintenance event start? This becomes a real compromise. I've always worked with the maintenance event starts when the operation says the equipment's not available. Now, that can conflict with maintenance point of view because the drill may be at a face and the fitter or mechanic has to travel to the face to be able to even assess the repair. But I'm going to advocate that that should be maintenance cost, or if you've got to drive the vehicle from where it's working back to a workshop, that's all part of maintenance cost. It becomes more complex when you have situations like maintenance want a vehicle for planned maintenance at the start of a shift. So the operator is told by a supervisor to finish work early and take the vehicle to the workshop and park it there. And then it sits through shift change and maintenance actually start work on it at the start of the next shift. Where does that maintenance event start? Does it start when maintenance start working on it? Does it start when it's parked at the workshop? Does it start when the operator leaves the face to travel to the workshop? So no clear cut, you've got to come up with a set of rules and just apply them consistently. The other end, maintenance get a little bit back here in that a maintenance period, I'm advocating it should end when maintenance notify operations that the equipment's available again. So even though the equipment can be at the workshop and operations have got to take it and travel to the working face, then that's operations cost. So these are just compromises and they tend to work fairly well. So once we have these three boxes, we can do calculations like utilization, availability, and utilization of availability. And they should all sum to calendar hours rigorously. We then tend to try and break up these boxes into subcategories. Underutilized, which basically is our engine's running or it's using power. I've used a very old terminology. I think it originally came out of Caterpillar. Direct operating hours and indirect operating hours. Direct operating hours can be called other things, productive, effective, operating. This is when the equipment is doing its primary job. And in underground, equipment can have more than one primary job. For instance, an underground jumbo can drill face holes for blasting and can also drill bolt holes for ground support. So it can have two or more kinds of direct operating. That's a bit of a differentiation between open pit and underground. Typically in open pit, most equipment will have one really prime task. Shovels load trucks, trucks haul, and so on. But in underground, it's quite typical for equipment to have more than one primary task that it does. Indirect operating. This is still underutilized. This is when the equipment is working. So in our crude model, its engine is operating. And these are the things it does that are not its primary job. Now, it should be stressed, these are essential. So in underground, our biggest one is traveling between workplaces. So Jumbo completes one heading and he travels to his next heading. Many places regard loaders, boggers, muckers, scoops doing a cleanup as part of the indirect. And I've seen various different names used, non-productive operating. The word support is actually quite good, but unfortunately in the underground it would get confused with ground support. Moving on to standby. Standby is actually quite simple. There's a really limited number of reasons why equipment is not working. I mean, no work, no operator, no access, and a few other things, no services. And then we have some process things like lunch breaks, shift change, meetings, and of course, emergencies. There's not a huge number of reasons why a piece of equipment is in standby. Maintenance, we come back to the curly one again, that there's always lots of discussion. I've chosen to break it up by two simple categories, service and breakdown. I've seen many different ways of breaking this up, preventive and corrective, planned and unplanned. They all have subtle differences. I've worked with sites with, say, the box I've called breakdown here is the events that fall into mean time between failures, and the service is all the other maintenance events. There's no one right answer. We're lucky we've got Zolly Lucas on the call today. He was coordinator for the Global Mining Guidelines Group developing their time usage model. We'll have a quick look at that. I don't want to go into this in any detail, but I point out their red box is orange, and it's called downtime. But you'll notice it's not broken up into subcategories. And I spoke to Zolly about this. He pointed out that they had a lot of difficulty coming to any agreement on how those categories should be broken up. So perhaps he can comment on that later. The word delay. I don't like the word delay in the time usage model. I suppose I've got to justify myself for saying that. In the classic open pit dispatch systems, the original modular mining and Jigsaw and some of the children that have come out of that, delay has a very specific meaning. It's a short stoppage that we have a fairly confident estimation of its duration that we can feed into the dispatching algorithm to reassign trucks. So in that sense, it covers a subset of these. That's one definition. If we used a product like Cat Mindstar, the word delay is used to apply to all of these. So we've immediately got two different definitions. It starts to get confusing. Now you'll find in a lot of time usage models, the yellow box is called delay. I'm going to argue against this on the basis that these indirect tasks are things that have to be done. They're not a delay, they're part of the operating cycle. I also had it expressed very articulately to me by a very good mine manager who said, my loader operator, my best loader operator is the one who does the most cleanup. And I don't want cleanup to be called something negative like a delay. These are not negative things. They're positives. They're things we have to do as part of the cycle so we can do our direct operating. So we'll cancel delay out of that box. So I'll assert a contentious rule that we shouldn't use the term delay in time usage models. Okay, then we try and drive down into more detail. So I've taken a set of detailed statuses which roll up into these boxes from a site. I haven't edited it. I think they're reasonably good. I tend to use them as my first pass when I'm setting up a new site. These are for underground. You would use a slightly different set for open pit. So these are a bunch of direct operating statuses. The top one, the generic operating, is in there, I think, just to accommodate the particular system they were using. It's come from history of open pits. We have the situation where equipment only really does one job. So by saying it's operating, we know what job it's doing. We're in underground. Say, for instance, a loader. In Australia, they're called boggers, and we do bogging rather than mucking. It can be bogging or mucking or loading. It can be teleremoting. It can be doing backfilling. So it's got there at the top 101, 102, 103, and 104, 3 different primary direct operating categories for a loader. And then 105, 106, and probably 116, 117 all belong to development jumbos. So each type of equipment would have a few of these. And we would typically expect in underground that most equipment would have more than one direct operating category that it could be used for. Transmixer trucks being used as water trucks and so on. The indirect, the big one is traveling or tramming. Cleanups I've mentioned, setting up, rigging down, cleaning equipment. Typically, if the engine's running, it would go in this box. If the engine's not running, then we'd probably put it into standby. Standby, as I said, there's not a huge number of them, and we can group them. We've got the equipment's not required, so there's no work, there's no operator, there's no materials, no services. We can have the process things like shift change, lunch break, meal break, crib break, safety meetings. So only a few, and we've expanded out into a few subcategories there. Maintenance, going with my division of maintenance into service and breakdown. So we can have services that are duty cycle based, or we can have services that are periodic. Typically, because there's no 1 meter on a jumbo drill that tells how much work it's done, typically drills will be serviced on a periodic basis, where most other equipment will be serviced on the basis of its hour meter. And breakdowns, here's a list. I think there's an absolute maximum list. So it's all subcategories of the equipment itself. So most equipment items would only have a few of these, and there's a greater portion of them are for drilling equipment. Little horror story. I had a client who had a very large company that had multiple sites, and an overzealous maintenance manager came up with a list of 196 breakdown codes that were to be collected by the control room. And he rolled this out very diligently across 3 mines. 3 or 4 years later, I did some analysis for them, and I found that of the 196 detailed breakdown codes, less than 50% had ever been used, and 90% of the hours recorded were against 15 of the codes. So I would really advocate that you don't try and go for too much detail. This, I think, is an absolute maximum in your time usage model. We'll talk about more detail further through the talk. So there's about 70 codes there, and I think for an underground mine site, that's about a maximum. somewhere between 50 and 70 should be the upper limit. So that's the end of the first part of this discussion, where we've gone back to some first principles and tried to develop up a simple, basic time usage model. Now I'm going to go on to, I'll repeat rule 1. You always take into account that you have to be able to capture the data you're trying to consolidate for measurement. Now I'll move on to what is the basic theme of this paper, that our systems haven't kept up with our thinking, and there's lots of things that they're weak in, and we need to start pressuring the vendors to catch up. Now, I hope there's underground people in the room don't throw things at me, but I'm going to use an open pit example in the next couple of slides. Open pit's a long way more advanced than undergrounds in capturing data automatically. So here's a simple truck cycle. One of the major open pit dispatch systems that I've worked with can automatically generate events with the truck and loader interaction and the truck behavior. They have some mandatory simple events for the interaction between the truck and the loader, which is recorded against the loader, or the shovel. And then they have a bunch of events that are recorded against the truck, and these are generated automatically. So I want to go in and do a little worked example on this. So if we have trucks coming and going from a digger, this is a list of the timestamped events that are automatically created for the digger, the loader, the shovel. Now we can see that the digger performance is compromised by looking at his live dig rate, but nothing in this list of events tells us why. Now, typically, we would go back to the digger operator to tell us why he's not performing. In this case, the digger was in hard digging. The blast hadn't worked well. And that condition endured for this whole period. So on one hand, we've got a series of timestamped events about what's going on at the digger, but it doesn't tell us why he's got compromised performance. And I only know of one of the major systems that actually separates these two out. Because if we put these detailed FMS digger events into the timeline for the digger, we lose that ability to have the overriding high-level event and its duration. So we're starting to build up a picture where, hang on, there could be multiple layers in this. And I'll move on to maintenance because it comes through stronger there. So I'm going to assert that these detail events should not be part of the main line of the events for the equipment. So maintenance events, we can have an event recorded. So on 10:43 on the 20th of April last year, an operator called from truck 305, I've got an engine problem. Now, typically, most sites will want to know more about that engine problem and want some detail. Unfortunately, the equipment operator generally is not the person to provide that. So it's quite common to have a list of subcategories under each maintenance category. So in this case, the mechanic or the maintenance supervisor goes out to the truck and has a look and says, yes, the problem is a radiator. I'm going to argue here that this is adding information to this event. We've got a raw event that's been captured and we're adding further information to it. This information can be generated at a later time than the event occurred, but it's related back to the time of the original event. So we're adding information. We don't overwrite the engine event with radiator. And this gives us immediately two levels of reporting. So I'm going to argue that the detail of maintenance should not overwrite the original tertiary status. So we need a facility where we can add value to the original status. And most of our systems do not offer this capability. Similarly, extending this concept, there's always the big argument between accident damage and failure. Here's an example of a site that had a code for accident damage. And so anything that was accident damage was recorded as accident damage. We don't have a lot of information there. We don't know what the accident damage was and what the maintenance resources to fix it would be. So I'm going to argue that we don't do that. We have our state we had in the previous slide where we had an engine problem reported, it was a radiator. Then we can have a process, and this can occur later, the next morning, of arbitration between the operations and maintenance. I'm told this picture is wrong. They should be standing back with fists clenched, ready to thump each other. And come up with an agreement, whether it was failure or damage, and add information, flag the original event that it was damage. And really, I don't know of any of the major systems in the marketplace that do this. Heading off down the same path, we'll have our assertion, we shouldn't have damage as a tertiary status category. We should stick with our regular statuses and then flag that event. And again, this information will be added a day later, but attached to that original time that the event occurred. We have this thing called opportunity maintenance that people tend to go on about. In my earlier statements, I said I felt the red box should be maintenance, should be all maintenance, and should be only maintenance. So it's a case for identifying whether maintenance is carried out in a time that doesn't, or a period that doesn't impact the operation. And that's typically called opportunity maintenance. And in some indicators, it's excluded from maintenance for availability calculations, etc. And that can be quite valid to incentivize people to coordinate the maintenance work with the operation. But if we have a status of opportunity maintenance as a tertiary status, we lose what our original maintenance event was about. So once again, I'll advocate that we have a process of arbitration between operations and maintenance and agree that this was maintenance that was done in an opportunity, that is, when the equipment was not required by the operation, and we flagged the event. So this belongs to the original time-stamped event, but it means we can report and extract what maintenance was done in an opportunity and what was done in regular maintenance time, and without compromising the information we've already gathered about that breakdown. So I'll assert a rule, and as far as I know, none of the major mine control systems have this capability. So straightening that picture out a bit, we've got a maintenance event that occurred. That was an engine radiator, it was damaged, it was underground, and you backed into a rock bolt. And the truck wasn't needed, so it was fixed in an opportunity. Now, this event for the vehicle endures until it's fixed and back on the go line. There's a whole lot more happens in between. I call these waiting events, where we've had our major event and we've been able to add value to it, but there's this parallel set of events that occur, which are sub-events. So traveling to the workshop, waiting to be assessed, being assessed, wait for parts, wait for labor. We all know those things on remote sites. These are important, and people want to know these, and people want to know these in real time. But if we put them in line with a single linear timeline, we lose the whole duration of the event. Most of the systems handle this in some form. I don't really handle that well in most products. Tend to put all these events in the single timeline and then flag them out for mean time between failures calculation. I think it can be handled a bit more adequately. Probably useful here to sort of point out that most of our mind control systems handle the first level of this information. Then we have maintenance management systems, but there is actually a gap in between. In fixed plant, we tend to have a discipline called delay accounting. And I think there's a gap there to be filled between the real-time control room dispatching type systems and computerized maintenance management, which tends to deal with durations rather than times. So we still have a gap in our landscape of systems, which doesn't allow us to add information in many of these cases. So I'm going to say the weighting statuses shouldn't be tertiary statuses. They should be handled differently, but they're very, very important and people need to see them. People even ask for them to be displayed in real time. Okay, I'll get a little contentious here again. I don't think the division between scheduled and unscheduled belongs in an equipment time usage model. It's one of those things I struggle to articulate. Here's an example of one time usage model block diagram that I've come across where they've tried to break up scheduled and unscheduled. They're using the word downtime, not just to mean maintenance. And you see you get a whole lot of duplication of cells, not very elegant. I think schedule is a different dimension from what we're talking about in a time usage model. It's important, no question about that. I'm trying to articulate why I don't think it belongs in a time usage model. Came up with a couple of things. The schedule's about the process, where a time usage model's about the equipment. The schedule is about times, it's about when, where the time usage models, we're consolidating all those durations. And I think the best example is if we take a jumbo that's drilling at a face, he's in a schedule window and he's drilling away quite happily. The schedule window ends. What changes for the jumbo? Absolutely nothing. He just keeps drilling till he's finished the heading. So I'm going to argue that while schedules are very, very important and we need to find a way to fit them in, they don't belong in the equipment time usage model. They're a process thing. I love the term, an artificial construct. Limping equipment occurs both in underground and in open pit. Underground, we have jumbos that have multiple booms, usually 2 booms, and one boom can become unserviceable and the jumbo can keep operating at a compromised rate for the other boom. In open pits, we tend to have electric hydraulic shovels that have 2 engines. One engine becomes unserviceable. It can still keep operating, but at a much lower rate. I really don't know, and I've never seen a good way of handling this in time usage models. I've come up with the argument that if we have Jumbo 40, it's got a very low rate here, and it was because Jumbo 40 was operating with 1 boom. So my argument is that when we have equipment that is operating in a compromised manner, we should always, when reporting its performance, we should report why it's compromised. A little one, especially for underground. Most of the systems that have come into control rooms in underground initially started in open pits. And underground is far more mature in the way it manages locations as assets. We need to know heading status, effectively where is the work. But that doesn't happen to the same extent in open pit. So these systems that have sort of morphed into underground from open pit typically don't handle location status very well. And what that's led to is the sort of workaround of trying to use equipment statuses for a location status. But waiting for a geotech assessment is not an equipment status, it's a location status. The equipment status should be there's no work. So I'll argue that we shouldn't try and use equipment statuses to manage location statuses. We can have quite a strong relationship between them. So for instance, when a jumbo completes drilling out a heading and departs, we can automatically generate a location status that the heading is now ready for charging. So there's a close relationship between equipment statuses and location statuses, but equipment statuses are not location statuses. So I'll assert one of my rules. You can see that not all the rule numbers are sequential and we haven't done them all. The written paper that goes with this has all the rules in it. So to summarize, with equipment time usage models, we unfortunately give people an incentive to bias the data. I was in a meeting recently and someone asked me, how can we fix the time usage model data? And I said, get rid of bonuses. We haven't got completely automatic capture of status data. So we're depending on people and then we're giving them incentives to bias the data. I'm not sure how we're going to solve that. I mentioned too much detail. It's only have in your model the amount of data that you can actually capture. And I've gone through a number of areas where our systems that are available to us are inadequate at the moment. So I'll finish with rule 18, which is always capture the data in a clear, honest, unbiased manner. So to finish, I have one piece of advice, and that's principle 2, stick to principle 1 at all times. Thank you.
Thank you very much, Ray.
Thanks, Alex.
So now
okay.
we have time.
Can I ask Zolly Lucas, are we still here? Yeah. Zolly, you headed up the GMG team on the open pit time usage model definition. Would you like to make a comment?
I'm just going to here get my system set up here.
Zolly's in Alberta and I'm in Perth, and we actually have a friendly relationship.
Yeah.
I'll stress I was an outspoken critic of the work they were doing, but we stayed friends.
It's a friendly it's a friendly collaboration, or what, friendly competition or collaboration. I think the one thing that is it is clear that I think there's a lot of value in having the time model, and the lot of areas of agreement in that we do have to focus on the equipment, and the tendency is to focus on managing people's performance and process. And I think that's one of the things we have to be careful of, is separating the equipment performance from process performance. You can still use the information that way, but you have to be clear on how you're applying it. Also agree that there is a tendency to manage the data to get the answers you want. And that's why I think the better your definitions of your events and activities, the better chance you have of getting an accurate representation of your operation. You know, so a good example is the maintenance example that Ray talked about. I think it's very clear, and it's sometimes the FMS might help in this, the dispatch systems, is if the piece of equipment goes down, then it's in maintenance, regardless whether it's waiting or not. And that's where jumping ahead to Ray's, I forget what he called it, but the tracking the in-progress status, the travel, the waiting parts, waiting labor. I think having a short interval control system in maintenance helps to identify those kinds of delays. The one thing that I would like to address, though, is going back to the maintenance comments. And Tim Skinner is on the line with me. He's worked a lot with these systems and setting these systems up and production management systems. And he was involved in helping develop the GMG time model. Agree that maintenance should not be measured in the operational time model. And one of the reasons is there just isn't enough, well, it overly complicates the time model. And one of the issues is that the people entering the information in the time model are operational dispatchers, and they may not have the correct information. So it may be a little bit, the information that goes in there could be pretty subjective. So we strongly advocate that maintenance, performance, downtime should be measured in a separate maintenance system. And that gives the opportunity to collect the kind of information that Ray was talking about. What he calls the tertiary status. We basically, that's equivalent to the component in the way we look at it. You can measure the component that went down, the reason it went down, whether it's failure, planned, PCR, or breakdown, and then what's the cause? Is it damage, wear out, lack of lube, whatever? Basically, the more information that the reliability engineers have to understand why a unit went down and what failed, is the better the opportunity they have to eliminate that source of downtime. So, we could talk about, the GMG time model. It looks at things a little bit differently, and it could be another entire half hour or 1 hour presentation. I'm a little bit caught off guard here, but
I think we're getting near the end of our time, Zolly.
Yeah. So I think there is a lot of commonality. And the one thing that I agree with Ray is I think we do have to engage the dispatch system manufacturers in kind of aligning with the way the operations look at the time.
Thanks, Zolly.
Thank you. First, let me open up questions to anyone who's on Zoom. Raise your hand or feel free to type it in the comments. While we're waiting, my question was, how much overlap is there between time usage models in other fields compared to mining? Because it seems like this would be ubiquitous as far as an efficiency measurement. So how much overlap of information comes outside of mining, and how much of basically cross interdisciplinary conversation is there?
It's definitely across the whole of any industry that uses equipment. I've focused here on mobile equipment in an underground environment, but I think it applies pretty much equally for open pits. I think in a lot of ways, this is a subset of what applies to fixed plants. I think fixed plants of any industry are probably a little bit more advanced than we are in mining in this kind of thinking. They have the advantage of being able to capture a lot more detailed data automatically because their equipment's not moving around all the time. So I think the fixed plant industry And if you go back to the Purdue study, they got their act together on interoperability between PLCs and the whole SCADA and data capture field. So mining could learn a lot from fixed plant, I think, but fixed plant doesn't understand the mobility. But the road transport industry is quite advanced and is moving very, very quickly. And this whole thing comes into the question of automated vehicles or autonomous vehicles. So yes, it's pretty general. I've focused on a fairly narrow industry segment, but I think most of it, the high level concepts certainly apply across all industries.
Before I use all the time, do you have any questions in the room? Okay, your answer fed into my second question really well. Underground communication has been improving rapidly in recent history. I'm not a mining engineer, so I'm not on top of all of this, but has improved Wi-Fi and other communication methods changed the way time usage models could even be approached because of the improved communication?
Funny enough, I don't think yet it has improved things very much, because we still have this challenge of getting robust data communications to working faces. It's a lot easier to keep a degree of analog voice communications up to a face than it is to keep Wi-Fi or LTE. Lots of people are working on it. One of my colleagues says, I'm not going to accommodate that. I'm just going to assume it's going to be fixed and someone will find a way. But yeah, it's a real limiting factor at the moment. The capturing data either automatically on vehicles or by operators using tablet devices on vehicles, when they go out of communication range, and there are various techniques. The most basic is that when they come back into communication range, it gets uploaded. And there are other techniques called data muling, where another vehicle, say a shift supervisor's vehicle, will come close to the mining vehicle that's out of range and automatically download its data. And then when it returns to radio range, the data will be uploaded. This does change the behavior in the control room. You tend to get a lot of guessing going on and events being created manually in the control room because they haven't received them from the machine. And then those are edited out again once the real events are received. So it's actually had quite a big impact on control rooms and the behavior in the control rooms. Sadly, it's created a lot of manual editing, which becomes problematic.
Thank you. If there are no more questions, I would like to finish up the talk since we're just about out of time. Thank you, Ray, so much for giving the time or taking the time and waking up early to give us this talk. It will be recorded, so it'll be available on our YouTube channel. As a reminder, the seminar series takes place every Wednesday at 4 p.m. Mountain Time. You can find more information about the speaker series on the mining department website at mining.mines.edu and on the department LinkedIn page. Thanks again to everyone who attended. We look forward to seeing you next week. And before I sign out, thanks again, Ray. See you next time in chat. Okay.
Thanks for the opportunity. I'll send you a link where the written paper can be downloaded, and if we can include that on the posting on YouTube.
Sounds good. We can definitely do that. Thanks again.
Thanks, Ray.
Thanks very much.
Nice work.